Okay, so we were saying that evaluating the non-discounted payback period can be a good indication if we should continue the analysis or not. Okay, so if I consider for type A, we said to evaluate the non-discounted payback period, we said the following equation that the net value, okay, which is benefits minus cost, should be equal to 0. And we need to find what is the year N, which will give a net value of 0. We said that the investment was minus 30. The operation cost is constant, so we just have to multiply the number of years by 0.6, which is 2% of the initial investment. And as we said, we divided by 1,000 to simplify calculation. So the value that we'll obtain is evaluated in 10 to the power $3. So this is times 10 to the power 3. Okay, so N times 0.6. Now, concerning the income is not constant with years. Here we should decompose. So for year 1, we gain $6,000, so plus 6. We have for year 2, it's plus 5. And it's 4 for the remaining years. Yani we do plus 4 times N minus. So since already we have 2 years, yani what if 4,000 is from year 3 to remaining years, so we should do plus N minus 2 times 4. And since the salvage here, please, as usual, we don't account for the salvage value when we calculate the payback period, because we consider that the payback period should be smaller than the lifetime of the system. And the salvage value, we only can profit from it at end of lifetime. So this is equal to 0. So we can calculate according to this. We can calculate the value of N. So here, we just have to say we have, here it's plus 4N minus 8. Okay, so we have minus 30 plus 11, which is minus 19. Then minus 8, minus 27. And we have 0.6N plus 4N. So plus 4.6 N. Okay, so equals to 0. This will allow us to get the value of N. So in case N is, so let me make sure of calculations here. Here plus 11 minus 8. So plus 3 minus 30 minus 27, yes, plus 4.6. So if we do N is equal to 27 over 4.6.
Professor,
Yes?
this is for the non-discounted payback period.
Yes, non-discounted payback period, yes. For option A.
But do we count the costs or the cost in the yearly cost?
We considered the costs. Yes, we have
We have 1% land. 1% of the
for type
investment.
A, We have 2% of the initial
10%
investment.
in $600
نعم.
$600 صح؟ هي إذا بتكون صح؟
لا بس نحن أخذنا 30,000. نحن we divided by 1,000. Yes, sorry, yes. So 30 times 2%. Okay. بس نحن مش we divided by 1,000.
Yes.
يعني
بس إن هي 0.6
يعني
هون.
you will obtain here 60 over 100, which is 0.6.
But do we subtract it from the 4 and the 5 and the 6? No.
No, look, whenever here you considered it, oh, sorry, okay, I see what you mean. We did plus instead of minus. Yes, of course. It's a cost, not an income. Yes, we have a minus here. Sure. Okay. So we have here minus. So this was the issue because it's a cost, not an income. We considered it an income in the equation. Yes, of course. So minus 0.6 and so then we have 4 minus 0.6, 2.4. Okay.
It's 3.4.
3.4, sorry. 3.4. Okay. So n will be equal to 27 over 3.4. Okay. Which is relatively high. Okay. So if we calculate the value, can you please do it on the calculator? 27 over 3.4.
7.94.
Okay. 7.94, which is nearly equal to 8 years. So which is very close to 10. So from this calculation, we can expect, okay, already that since the payback period, the non-discounted payback period is really close to 10, the performance of the project might not be good. And from here, we can question the performance of the project. And already this is a good indication that the project might not be profitable. Okay. And also we can evaluate if you want. And here, if we do the questions in the reversed way, no need then to continue. And if we do the first payback, the non-discounted payback period, and if we calculate the maximum discount rate for which the project is profitable, we'll obtain a very small value of discount rate. So from here, since when we do calculation of maximum discount rate, for which the project will be profitable will get a relatively large, small value, we can say, of course, for discount rate of 8%, the project will not be profitable. Yes, Salma?
Are we responsible to do it for B because not for A? No, that means for non-discounted payback period for B.
Yeah, Anna, I'm doing extra question here.
Okay.
Yes. So if we do the calculation for B, I will do it for B. But we were thinking together, if you want, not in the same context of questions of the problem. If we have this problem and we want to do its analysis, what is the best approach to start with? You can start, because the calculation of the non-discounted payback period is really simple. You can start with it. And it will be an indication for you if you continue or not. And if you get a non-discounted payback period of 8, which is close to 10, you can say it's not attractive. No need to continue with analysis. Okay. The same for B. And if we take B now, if we take B as option, and we want to calculate the non-discounted payback period, similar method. Okay. So we'll divide by 1,000 first to simplify calculations. Okay. So the value I obtain should be multiplied by 1,000. So first, I have for project B, the initial cost is $55,000. So in my equation, I put first minus 55. I can put here times that the result is times 10 to the power 3. Okay, so I have minus 55. Concerning, they said that 1% of the operational cost constitute 1% of the initial investment. So minus 0.55. And since it's constant over years, so minus 0.55 times the number of years n. Now, similarly here for the income, they are variable with years. So plus 9 plus 8. And for remaining years, it's 7. So plus 7 times n minus 2. And here also, we don't account for salvage because we are calculating the payback period equals to 0. So here we develop this. It's 7n minus 14. Okay. So we have 9 plus 8, 17. Minus 14, it's plus 3. Minus 55, so minus 52. And for n, it's 7 minus 0.55. So it's 6.45 n equals to 0.
5n.
Okay. So here also n is relatively large. So if we calculate n is 52 over. So it's also around 8, صح? It's also around 8.
Yes, 8.06.
Okay. So also around 8, which is a bad value because it's close to 10. Okay. So if we just do this calculation, and if we are facing this problem in reality, we can say that the payback, the non-discounted payback periods are not encouraging at all, and the projects are not attractive, and we can stop here. No need to continue. Okay. If you want to do further analysis, if you want, you can calculate the maximum discount rate for which the project will be profitable. So if you want to do this,
Doctor, what is 0.55n?
0.55n is the operational costs, because you have the annual operation cost for type B is expected to be 1% of the initial investment. So you have 55,000 times 1%. So for each year, you need to pay $0.55,000. Okay. And since it's constant with years, you multiply by n. Because here I divided by 1,000 to simplify calculation. Yani your cost per year is $550, okay? But since I divided all terms by 1,000, it's 0.55 times the number of years, which is n. Okay, Rida?
Clear. Thank you.
Okay. So now, next step, as we said, if we want, already the non-discounted payback period is not encouraging, we can stop. Or also, if you want to know the range of discount rates that we can work with, we can calculate the maximum value of discount rate for which the project will be profitable. So we say, in general, for the project to be profitable, we set a CER that is equal to 30% of the investment. So 0.3 times I. Okay. So let us write the equation that will allow us to determine the maximum possible discount rate. Let us do it, for example, for type A. Okay. So for type A, now I have to consider discount rate into account. So I will write, I want to determine the net present value should be equal to 0.3i. So the investment for case A is 30. So 0.3 times 30. Again, okay, all terms are times 10. So I do this equation times 10 to the power 3. Okay, so 0.3 times 30 equals 2. So this should be my net present value at end of lifetime. Okay, so since I am considering the whole period of 10 years, here I should include the salvage value. Okay, so I have for year 0 I have the investment, so minus 0.3. Now, for the operational costs, okay, we said that it's for project A, it's 0.6, and we need to do the summation. So minus summation from year 1 to year 10. Okay, of 0.6 over, here A is the unknown. Okay, we want to find the maximum discount rate. So the value of the discount rate, which will give a CAR of 30%. So 1 plus A to the power I. Okay. So this will give me the operational cost. Now for incomes, as we said, we need to divide into, the summation will be divided into 3 terms. So I can do, because I want to do summation for I going from 3 to 10. Because after year 3, the income will be equal to 4,000. Which is 4 if you want, because I divided by 1,000. So 4 over 1 plus A to the power I. And now for the first 2 years, I will account for my terms separately. So plus for year 2, it's 5, yani 5 over 1 plus A square. And for year 1, it's 6,000, so 6. So plus 6 over 1 plus A. Now, to be able to use the formula that I have for the geometric series, I need to write the summation from 1 to 10. So I just can replace that this is summation from 1 to 10. I can take 4 outside, 4 times. Okay. Summation from 1 to 10 of 1 over 1 plus A to the power I, and I subtract the first 2 terms, yani minus 1 over 1 plus A minus 1 over 1 plus A square. Okay, and now I can rearrange my terms. So the equation will be of the following form. So 0.3 times 30 of course, I can take this term to the other side. So 0.3 times 30 plus 0.3, and 0.3 times 31 equals to, for the summation from 1 to 10, so I have first summation. You can take into factor, if you want, the summation from 1 to 10 of 1 over 1 plus A to the power I this summation factor of what you have here, minus 0.6, and you have here plus 4, okay? So you can, to reduce if you want, because you want to put it in your calculator, you need to reduce as much as possible. Okay, so I will take in factor here, minus 0.6, plus 4. Okay, and now I will group also the terms that are common to 1 plus a and 1 plus a square. So I have a 6 minus 4, so it's over 1 plus a, so plus 2 over 1 plus a. And I have 5 minus 4 over 1 plus a square, so plus 1 over 1 plus a square, okay? And now you can put this equation on your calculator and put shift solve. So you can take this term to the other side. So to have equal to 0, you take this term to the other side, you write your equation, function of a, and you put shift solve. The calculator will give you the value of a. If you were not able to do it in the calculator, if the equation was very large and you are not able to do it on the calculator, you can do trial and error, okay? And here, because when you did calculation of non-discounted payback period, it was really large, you can expect that the maximum value of discount rate will be really small. So you can start, for example, by 2%. Okay, you put a equal to 2%. If you get a negative value here, you should have equal to 0. After you take this term to the other side, should obtain equal to 0. If you get a negative value, this means that you should reduce your discount rate. So you reduced your discount rate, let's say, to 1%. Okay, then you will get a positive value. You say the discount rate is between 1 and 2%. So here it's nearly 1.3%. Okay, so you can say that from trial and error or from calculator that the maximum acceptable discount rate for the project to be profitable is 1.3%, which is really low. It's very low. Okay, so you can just suggest this project for a very restricted range of investors, because in general, the majority of investors will expect a discount rate in the range of 10%, 15%. So a value of 1.3% is not attractive at all. Okay, so you can directly say from your analysis now that if I consider, of course, a discount rate of 8%, I will get negative NPV and I will get negative CER. Okay. So to find these values, if you want to find them numerically, all you have to do is to take your equation and replace A by 8%, okay? Then you can assess what is the net present value. But you can expect from this analysis that you will get negative results for both options. So both options are not attractive for any discount rate above 1 point, for A, it's 1.3%. For B, you can do similar calculations in order to determine what is the value of discount rate, of maximum discount rate, but it will also be in this range, and it is very small, okay? Because both gave nearly similar non-discounted payback period around 8, so we can expect that for both options, the maximum value of discount rate will be really small. This will limit a lot the range of the interval of discount rates we can work with. So we can expect that for normal discount rates, the project will be rejected. Okay, and in case we want to calculate the internal rate of return, also we'll expect to get a relatively low value, but of course it will be, and for option A, it will be larger than 1.3%, because already this value will give a profit. Okay, so all what you should do if you want to calculate the CER, all you have to do is just to to consider, you don't put here, instead of 0.3 times 3, you just say it should be 0. So if you put here 0, then the value of A will give you the IRR. Here also, or you put it in your calculator, or you can do trial and error. And also, because you expect the IRR to not be very high, when you do trial and error, start with relatively small values. And you can start with 5%, for example. Okay, if you start with 5%, you will get a positive value. This means that the IRR is a little bit larger. Okay, so you can try, for example, 7% will give you negative value. Then the IRR, sorry, is in between. So you can evaluate at 6%. Then you can do like linear interpolation, for example, between 6 and 7. If you get for 6 positive, for 7 negative results, you can do a linear interpolation between 6 and 7 for the IRR.
Professor,
Yes.
but please, for the exam, can you please lower the lifetime so that we can use it on the calculator, the formula? I know it was.
Look, it's not related to the lifetime. The calculation is not related to the lifetime. It's related if you want to the number of terms, and the number of terms that you have to input.
Yes, but this number depends on the
You mean the
number
time
of.
of calculation will be higher if the lifetime is larger?
What?
You mean that the number of terms will be larger? Yani the calculation time
Yes,
will be
because
higher? Because
yes,
because
we
if I
have a
tell you
sum from
20 years, yani, the lifetime will not affect the number of your terms here. If I tell you the lifetime is 20 years instead of 10, you'll just have here the summation from 1 to 20. So this will not affect your terms, but it might affect the calculation time.
but me on the calculator, I don't have the sum. I have to put يعني 1 over 1 plus A.
No, you have this. No, لحظة. You have first, any calculator will include the summation in general. If you don't have, you mean you want to use trial and error method? Look, you will replace the summation by this expression. You don't need to do if you want to do it by trial and error, you can replace the summation by this term. But look, if you have to include all terms, this means it will be very large. Bring a calculator. The majority of calculators can do summations. The normal calculator can do it. So just bring for this day a calculator that can do it, because even if I select for you a small, I already printed the exam, but even if I put 8 years, you cannot decompose into 8 terms. It will take a lot of time from you. Okay?
Okay.
It's very simple. Bring a calculator and learn how to do it. It's really easy. And in case you want to use trial and error, you don't use summation. You replace the summation from 1 to n of 1 over 1 plus a to the power I. You replace it by 1 plus a to the power n minus 1 over a times 1 plus a to the power n. So then in your calculators, the normal calculators that, and if you don't have a calculator with summation, you use this. Okay?
Okay.
Okay. Other questions? Now, for question 3, they ask to find the non-discounted payback period and the discounted payback period. So for the discounted payback period, what should we do? We just have to write,
Just add the interest rate.
Yes, we don't put the salvage value and we evaluate it. Here, if you want, the results will be for 8%. We can expect, because 8%, if you calculate the CER in part 1, you will get, and internal rate of return, you get negative CER, and you will get for your IRR 6.2 and 6.4%. Okay, already, if you want, no need to do calculation for the non-discounted payback period. You can directly use the small analysis. You say, since 8% is larger than 6.2% and 6.4%, which are the internal rate of return for options A and B. So I can directly deduce that the discounted payback period will be larger than the lifetime. Okay, so it's meaningless to calculate it because we do calculations when we expect to have it smaller than the lifetime. But because the value of internal rate of returns are smaller than the discount rate and the NPV is negative, so we are not able to pay back our investment before the end of lifetime, and will never get NPV equals 0 during the lifetime of the system. So you can, if you want, no need to do a calculation in this question. You can say I will have, since I get negative NPV for this discount rate, then the payback period is meaningless because it will give me a value larger than the lifetime of my system. Okay? So you don't perform calculation here, because if you perform it, you need to put the salvage value here. You know why? Because you exceeded the 10 years. And after 10, I cannot gain any more. Yani the result is not the result that I will obtain is not reasonable. Okay? So no calculations will be made here. You should just say this interpretation, 8% larger than IRR, so I am not able to pay back my system during the lifetime. Okay? If you do calculation, okay, you will get a value larger than 10, and you can do the analysis. You can say this is expected because the discount rate is larger than the IRR, so I cannot pay back my project during its lifetime.
And when we do the calculation, we don't have to put the salvage value, yes? Even
here, if you want, and here it's in reality, in general, we cannot, if you want, say to put it or not, because the meaning of payback period is that we pay it before end of lifetime, so we'll never profit from salvage value. So if you put it or you don't put it, already the result is not reasonable. You will not say, when you get 10, let's say you did calculation, you get 13 years, your system will not give you incomes for years after 10. The assumption that I will have income after year 10 is wrong already. Okay, so this is why I told you it's meaningless to perform the calculation here. Okay, if you didn't pay attention, no, you don't put the salvage value, of course, but when you get results larger than 10, you say I cannot pay back my system during its lifetime. Okay.
Doctor, can you repeat number 3?
Number 3, yes, sure. For option B, calculate the non-discounted payback period and compare it with the discounted payback period. Rida, you want me to repeat both, or the discounted payback period?
No, the analysis you've said from number 2 for IRR.
Okay, I said the following. In calculation in part A, you got values of IRR for the two projects. For one, it was 6.2%, nearly. And for the second one, it was around 6.4%. Okay? So when you consider a discount rate of 8%, you have that A is larger than IRR. And in general, why we calculate the IRR? IRR will give you an idea about the possible range. If the range of discount rates that you can address is large, it is good. And if you have IRR 20%, it's good because you can expect for any A below 20%, you will have NPV larger than 0. But here, since the internal rate of return is smaller, A is equal to 8 here. So A is larger than IRR. This means that the net present value for this discount rate will always be negative. Okay? So you already determined that it was negative at end of lifetime. So of course you will not be able to pay back your system, because to pay back your system, you need to reach NPV equal to 0. And since you calculated in the first question the NPV at year 10 and it was negative, so of course if you take any year before year 10, it will also be negative. So you will not be able to pay back your system, because even if you reach the end of lifetime, you still have NPV negative. Okay, so you can say, because you can do the analysis in several ways. First, from question 1, the NPV at end of lifetime is negative for a discount rate of 8%, and the CAR is negative. So for all years before, NPV was negative, because with years you will gain. As you go within your project, you are adding incomes, so NPV will increase. And the maximum NPV, which is at year 10, is negative. This means that for all other years, NPV is negative. Okay, that's why you can directly say I don't have a discounted payback period. It doesn't exist, because if I take the whole lifetime, I will still have NPV negative. Another way to do interpretation of this, you compare your discount rate to the internal rate of return. The internal rate of return represents the maximum discount rate that will allow me to just get NPV 0. If you have a discount rate larger than IRR, of course, your NPV is negative. Okay, and you already did calculation and you verified this in first question. So you can say, since A larger than IRR, and from my calculation before, NPV is negative at end of lifetime, I can deduce that I cannot pay back my system during these 10 years. Okay, so no need to do any calculation, because the numerical values that I will get from calculation is larger than 10, which is not reasonable, because my lifetime will end at 10 years. Okay?
Yes, clear.
Any other
هلا
question?
جاي very good from number 2.
Number 2, yes. Calculate the CAR for the two options, considering a discount rate of 8%. So what should you do here? You already calculated NPV in question 1. You just have to divide. No, you calculated IRR in previous question. Here, what should you do for CAR? You calculate the net present value at year 10, and you divide by the investment. To calculate the net present value at year 10, you should include the salvage value. You use exactly same formula we did before, but you add salvage value and you replace A by